for example, if we start with this one here, and you have a rectangular stained glass window that is 2 foot by 4 foot. You have 7 square feet of clear glass to create a border of uniform width around the window. What should your border be? Well, last time I checked, when I'm talking about word problems and things like that, I need to figure out what does it look like? Well, what does a stained glass window look like?
Rectangle.
Well, correct. It starts as a rectangle. So proud of yourself. I'm proud of you. So if we start with a rectangle, because it's 2 by 4, let's do that. Let's make a stained glass window. So there's one on my desk.
Oh my God.
So I start with my 2 by 4 rectangle. 2 by 4. What is the area of said stained glass window now? 8. So this has an area, beautiful. Oh, the orange didn't show up very well. That must be dead. Let's throw it dead. I know Anna's standing up right now saying, "Oh, we throw it out there because I'm better than her." You should be very kind to me right about now. Okay. So we have a. Oh, she knows. So we have this beautiful stained glass window that if it was sunny out and the sun was north instead of that way, we would have it shining onto these desks in this all of its glory, and everybody would look and go, "Oh." It'd be beautiful. But we don't, because it's cloudy and crummy out. So we have to finish reading the rest of the problem. Sorry, you don't get out of it. Now the rest of the problem says that you're going to put a border around this. So border of uniform width means what? It's the same all the way around. And not the steadiest of drawers. I would be squint, it's going to be just fine. So as you go through it, if it is border of uniform width, and I say that much is x, that much is still x, right? Just to make sure that it's the same width here, it's still value of x, still some value of x. I'm just showing that it's the same width all the way around by drawing this border of uniform width. Now, this border of uniform width has to equal how much in square footage? 7 square feet. But we have to figure out what the area is. All this problem turns into then is an area of shaded region that you did in geometry. But you have to come up with what are the new dimensions. Well, the dimensions of the picture plus the frame going this way is how much? Well, it's 4 plus 2x. Oh!
What just happened with this?
Going this way, how far across is it now?
2 plus 2x.
2 plus 2x. So I have now this beautiful stained glass window that has the overall dimension 4 plus 2 by 2x, 2 by 2x, 2 plus 2x, excuse me. And then I have to subtract out the area of the middle, correct? And what does it all that have to equal then? 7. It's a matter of drawing a picture. It's a matter of drawing the picture. Remember, you are starting with a 2 by 4 rectangle. It's 2 by 4. You have a border that's going to go around it, a border of uniform width. If it's a border of uniform width, that means it stays the same all the way around. So this is x, x. It's the same width all the way around it. throw that on there so you don't yell at me. It is not drawn to scale. Okay? So now, if you think about what was on the interior, our interior stained glass
That's pretty cool.
oh yeah.
Yeah, you should have filled it with a
If
different.
you're a left-handed, I could see.
Now, I have this beautiful interior stained glass window that has an area of 8. Think about what you know. Oops. You're trying to solve for the area, using the area of the border to determine the width. The area of the border was 7. It told you that. The area of the border plus the window was our 2x plus 2 by 4x plus 2. I'm sorry, 2x plus 4. Excuse me.
I thought it was minus, not.
What's that?
4 plus 2. Is it minus that one? 4 plus 2x.
I just put the x's first there. What were we saying, minus the what?
Why were you multiplying them instead of like subtracting them? Because it said in the box that you
I'm saying this new width here is 2x plus 2. This is 2x plus 4.
Oh,
So the
you're taking
area,
out of it, okay.
yeah. What I'm doing is I'm finding just the area of the border by subtracting out then the area of the picture.
Why is that 2x?
What's x plus x? And then you subtract out the area of the window. I love your shirt. That is great. Okay?
Stand on your shoulders. You're on the spot. He's sad that
It's Jason.
Here, it was actually.
You want to give me grief? I can have t-shirts made.
I think you should. I like the picture, Mr. Burger.
So here's what we do. Guys, FOIL out. We have 4x squared. Was it 4x squared, 8x, and a 4x is 12x, and then we have plus an 8, minus an 8. Bring this over, we have minus a 7. Equals, dun dun dun, 0. What's 8 minus 8?
0.
So now you have a quadratic of 4x squared plus 12x minus 7 set equal to 0. That sets you up for factoring, quadratic formula, putting the square and whatnot. First thing I always ask myself is, can I factor it? What's 4 times negative 7? What times what's negative 28 that you add together to get positive 12? What is it?
Negative 2 and 14.
2 and 14, negative 2 and 14. So I can factor this rather quickly without even going through the whole process of completing the square or anything else. I have 4x squared minus 2x. Then I have, oops, this should be a factor here. It should be then plus 14x minus 7. And now I take out the GCFs twice. Okay? It's a factoring problem with leading term coefficient not equal to 1.
Because you have to split the 2.
Yeah, just look at the terms so that I can
Take out the positive 7. And then there I'm factoring out your GCFs. Yes, ma'am?
Where did you get the, how did you get the 7 to be a 0?
I moved it over. I subtracted the 7 to the right.
Oh, okay,
Okay.
okay.
Going this way. So now you have two terms. You have 2x plus 7 and 2x minus 1 equals 0, which means I can find my two zeros. I have 1 0 at negative 7/2, and another 0 at 1/2. Which one's going to give me the right measurement for my border? The 1/2. There you go. Right.
Wait, how do you know this is
Can you have negative measurement?
maybe?
Nope. That's how you do it. Yes, sir. Oh. Yes, sir.
Where did you get the 14? I got one.
Factory. Just factory. I was multiplying tails together to get the middle. I did this. I did what times what is negative 28 that I add together to get positive 12. That is 14 and a negative 2.
Okay. Oh, okay, now I get it. I was really confused there.
Okay. It's okay. That's how these things. That's how a lot of these things work. When we have to start out, yes, sir.
I thought of another way to do it. Then we put quadratics. If you plug in the measure things, know that's 7,
Okay.
and you know that the window is 8. So then what minus 8 equals 7? 15. And then you can figure out the.
I just got lost in your language. I think I know that there are. I know that there are other ways for a lot of these types of problems, because believe it or not, a lot of these are logic problems, and you could figure out where you're going logically with a string of ideas like that. You probably aren't wrong. I just never in a million years would have thought of that myself. I don't think like that. That's okay. I'll look at it and see how you did it, okay? So, like I said, a lot of these things, we're going to be setting them up to factor. We're going to set them up to use quadratic formula a lot. Or we're going to set them up to use what are intercept form. Intercept form is one of the easiest ways to find max and min values for quadratic style problems, especially when they look like numbers on your sheet. I forgot which one it is. I don't have it on here. Number 74. 99. Flip over the page. Oh! Let that soak in a little bit there.
So smart.
I saw that. I saw it on Twitter. Daily Chronicle probably posted it.
Nobody hit that button. That might be.
The best.
That might be up there with like the Caleb going, no. You know, this one has I think a place in our hearts where I think we're just going to kind of. Where I do believe that this is just.
Beautiful.
Make it a little bigger on the other side. So
You know, I think it's. Oh. You're right out there with the Devin face and the Caleb face and the Mr. Fontana in his Walter Payton Ruse headband. So.
That's pretty cool, though.
Oh, Photoshop, you're so much. Actually, didn't Photoshop it. I just drew on it. All right, so. So awesome. Hey, gee, guess who got their tongue sticking out again? And then we'll finally talk.
Yeah, so Anna's face on.
Put hers.
Anna's.
Oh, and it's facing the ball? Oh, yeah, we can do that.
That's awesome.
Just wait till if we got a picture of you kicking something, I can flip it and her head's upside down. She's going,
Oh.
great.
Actually, I missed it.
All the fun we can have.
2 weeks ago, there was one of me kicking the paper.
Oh, I didn't see it. I'm
I
sorry.
know, you didn't. It's okay.
Wow, we're not, did you ever hear that? I know, you did it. Sorry, make sure when you exit the room, you turn sideways so your head can fit through, okay? Oh, man, I love my job.
Okay. That was appropriate. That was fine. Good.
All right, let's look at number 99. So, another... Anna,
That's the only major effort to see when you look at me.
it's just... That's almost ended that. So, one of the things that I want to look at here is another format for quadratic style word problems is cost versus sales types of problems. This is an example of cost and sales, because obviously we have sales of shoes and costs of shoes. So when I start this one out, when we read it, we have a shoe store sells 200 pairs of basketball shoes each month when it's $60 a pair. For each $1 increase in price, about 2 fewer pairs per month are sold. How much per pair should the store charge to maximize their monthly revenue? In this case here, you have two things to think about. You have cost and sales. So what I do is I write it out as a cost sales function. Now, I know that this word problem occurred somewhere in the quadratic chapter, which means it's going to wind up being a quadratic. So why not do this right away? Because that's what we're going to work with. We have some cost and we have some sales figure. And the cost of $60 per shoe, how many pairs of shoes do you sell?
200.
200. So if you start thinking about it in terms of foiling, 60 times 200 would give you your total revenue. Do you agree?
Yeah.
That's kind of what you're starting to think of. Now, it then states that for each for each $1 increase in price, how would you represent that?
X.
X. Are you adding or subtracting?
Subtracting. Or adding.
I'm adding $1 of price. I'm putting that 1 there just so that we remember that the X value, if it's $4, it's 4 times $1 gives me 4. You could be 4 then, okay? How much in sales do I lose?
2.
So it would be minus 2x.
X.
Because for every $1 increase, $2 drop. So if I'm selling it for $64, that means I went up 4 on 1, which means my sales would drop by how much? 8. Excellent. Everybody see how that works?
Yeah.
Now, I also want you to think about, is this going to be up like a cup or down like a frown? Well, it was kind of a giddy question because what's it asking you to find?
The
Maximum. Maximums occur when you are down like a frown. Also, notice if you did FOIL it out, you get a negative x squared here, don't you?
Yes.
Yeah. So this cost sales style problem is what I think the easiest ones to work with, aside from the hit the button on your calculator one. Because these are your zeros. You are already in factored form. All you have to do is set each one of these terms equal to 0 to figure out where they cross on the x-axis. Because once you know where 2 points cross on the x-axis in a quadratic, you therefore then have a set of symmetric twins. What occurs between every set of symmetric twins? The axis of symmetry. No matter how far apart they are, since these guys are going to be on the same horizontal line, they're both on the x-axis, the axis of symmetry is going to occur halfway between them, no matter what. What's your 0 for 60 plus x?
Negative 6.
What's your 0 for 200 minus 2x? 100. What's 100 plus negative 60? 40. What's half of it?
20.
So your axis of symmetry then is at 20. Because I know that from negative 60 to 20, and then from 20 to 100 is the same distance. They're both 80 apart from one another.
Use the arrow and divide by
That's all it is. It's a midpoint. The axis, when you're in intercept form, when you are in intercept form, that's why I was actually really upset that the new Pearson book did not talk about intercept form. Intercept form is one of the easiest forms to use because it's usually just getting a midpoint and you got your x value right away. So if your x value is 20, that means what should you sell your shoes for? $80. Means you should sell them for $80. And how many will you sell at $80? You will sell 160 of them. That's how it works. The midpoint is your axis of symmetry. There's your x value. Your x value then goes to here and here to tell you what you should sell it for and how many you're going to sell. That's it. That's it. Look at the next one. Very similar. Electronics. This one is very, very similar to it. The manager of a home electronics store is considering repricing a new model of digital camera. At the current price of $680, they sell about 70 of them a month. Sales data from other stores indicate for each $20 decrease in price, roughly 5 more cameras are sold. What should they charge per camera to maximize the monthly revenue? Then what would the monthly revenue be? So what you're doing is you're trying to figure out this value of x that is the multiplier of the price, the multiplier of your sales figure. Okay? You're going to come up with some sort of a cost sales quadratic. You have a cost and a sales. We know it's a quadratic. Cost sales problems are always going to be easier. Actually, they always set up via intercept form. What's my cost? At $680, how many do I sell?
70.
For every $20 decrease in price, so that's going to be out.
Minus 20x.
Very good. 680 minus 20x,
Plus 5.
and that's plus 5x. Because this value of x means if I take down $20, I marked it down one time. If I mark down $40, I marked it down x is 2. 60 is x equals 3. 80 is x equals 4, and so on. That's how this multiplier is working. You're going to be able to find that multiplier via the axis of symmetry. And then it'll be able to tell you what your cost and your sales will be. Okay? Again, we have this set up in terms of intercepts. So now all I have to be able to do is figure out my zeros. What's 680 divided by 20? Better yet, what's 68 divided by 2? 34. 70 divided by negative 5. Was it 14 you said? Negative 14?
Wouldn't you want to add the 0 back on to the 6, like to the 34? Oh, never mind.
I just dropped the zeros because I was saying, I was just saying what's half 68. What's negative 14 and 34? 20. What's half of 20?
10.
Because from here to here is 24, and from here to here is also 24. What you're doing is you're finding the x value that creates the midpoint. Yes, sir?
So when you like divide them or whatever, so it's the opposite of what the x would be, so because it's minus 20x.
So the max is what?
Whatever makes that equal is 0.
Think of it this way. You're solving this equation. That's all you're doing. You're finding the zero.
Oh, okay.
That's all I'm doing. So I knew that I'd add 20x and divide it by 20. I just moved it and divided. Same thing here. I moved it and divided, so I got
You're
negative.
basically dividing by the opposite of what the number is.
Always works.
So the answer is what?
My answer is the x value would be 10. 10 is the number of times I should mark it down. So that means I would mark it down to a cost of how much? Well, very good. So at $480 is my price point that I will sell the most cameras. How many cameras will I sell?
20.
I will sell 120 cameras at $480. This is kind of what happens in the real world. This happens all the time. How can you fluctuate your prices so that you are selling the most merchandise at the best profit you can make?
What job title? Wait, so you just plug
Merchandise, you can do a lot of it.
I'm just saying
What's
that.
that?
Plug X description back into the axis.
Yep. Because what happens here in this style problem, Haley, it's going to say at what cost is your best cost. Well, I found that midway point that's going to give me that value. That value is going to give me, all right, so if I put that back into my cost function, I put that back into my sales function, those are going to be my best bets. Okay? Now, the other problems that are on here, you guys got a little bit further along here than the other class did. The other problems that are on here, if I go back,
Wait, can you go back?
Old news, Mr. Murphy.
Can you go back to that picture?
Oh.
you know what? I actually have a really good idea.
Oh, God.
Yes.
He's right.
I'm scared.
Hello, 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 hello.
Is that gonna help ever reach down just that one?
Just that one.
My best picture yet.
You should put that in the YouTube.
It's great.
You should send that out to all of us.
No, that's not nice. But if you watch the video, I can't stop you from photoshopping it. Did I just say that out loud? I didn't mean to. Delete, delete, delete. Number 90 and number 91 are very similar to the border problem with the picture frame. Number 97 also is. But the difference in number 97 is number 97, they give you the outer perimeter of the wall at 50 by 30, and you want to make your mural on the inside of it. So instead of adding uniform width, you are going to be subtracting uniform width. Yes, ma'am? I want you guys to do the other one. I think there's 5 of them on the first front back page, and we'll talk about the rest of them tomorrow. Okay? Yeah. 98 is extremely straightforward. There's nothing crazy there. I did 99 and 100 for you. I will come up with another. I have a couple more cost sales ones we'll look at tomorrow. Number 101 I want you to try to figure out. Draw a picture is all I can say. Yes, ma'am.
Can we just do this?
The front page, front back of the first page. Front back of the first page for tonight. We will talk about the rest of it tomorrow. We will talk about what happens when we have other models. A lot of these things we're going to be able to roll through real quick, especially after you guys do question 101, because it kind of opens up how you do the rest of the problems. When we get to the other pages there, also when we get to the volleyball one, we have to talk about what's called initial velocity. Whether you're dropping an object or you're throwing an object into the air with velocity to start with. Yes, sir? Might not be a bad idea. I've tried to space it out. We had a little bit of room, but it'd probably be easier to do it on a separate sheet, okay? All right, then we're going to work through those. We should try and test this. So, and we'll go from there. So yeah, tonight, I want you to do front, back. There's what, 5 problems, I think? 1, 2, 3, 4, 5. Yeah, there's 5 of them. I will give you a hint. I will give you another hint on the front page. On number 91, guys, on number 91, you have to look at it in terms of they want to take the parking lot that they have right now and double that size, which means you have to start with figuring out what the area of just the parking lot itself was first, and then go from there. So it's another area shaded region with an area of shaded region. Okay, so there's a couple little shaded region problems in here. And it's all rectangles. We're not going to do anything crazier than that. We'll do geometric probability again like you guys did last year towards the end of the school year with probability, whatever it was called. Okay? You guys got time right now to start working? I got a good 10 minutes to go knock out the quilting problems. The same thing as the picture frame.